This is lesson 19. I will create and solve multi-step word problems from given tape diagrams and equations. So in this lesson, you're going to completely skip your journal because there's not going to be anything to put in your journal today. You're going to go directly to your problem set. So go ahead and get out lesson 19 problem set and let's get started. Okay, so you're going to notice, first of all, that it's going to look like I'm not giving you the problem set. But this is the very first question that is on your problem set. It's just a picture of a tape diagram, and we're giving you, or it's giving you this context. You've got to figure out from this tape diagram how to write a simple two-step word problem from the tape diagram below. So I want you to take a look at this tape diagram, and you'll notice that this is a single tape diagram, so we're not doing any comparing. We just have a total. Our total is 7,104, and we have three parts. We have 4,295, 982, and then we have part A. So they're giving us a context. This means we have to write a problem about people at a football game. Okay, so I'm going to go split screen here, and I'm going to type because typing would be much faster for me than trying to write this out. Okay, so I noticed that I have a total. So since my story says something about people at a football game, I'm going to start just like I would if I was given a word problem. Usually they give you the total first. So I will say there are, or no, let's say there were 7,104 people at a football game. So that's the total. So I have to come up with three different types of people. So since there are 4,295, I'm thinking since the football game has mostly lots of men like sports, so I'm going to say there were 4,295 men, 982 women, and some children. So notice I gave an exact amount of men, an exact amount of women, and then where it got to the next part where it says A, I just said some children. So I want them to solve for A. So I'm going to say, how many children were at the football game? Okay, so that's my problem. Now it says not only do I have to create, I also have to solve. So now I have to solve for A. So I'm going to come up here and get my pen. Okay, so I have to figure out, we've had several problems like this where we're given this total and then we're going to have to take away these two parts and whatever's left over is going to be A. So there's two ways to do this, but I'm going to go ahead and put the men and the women together. So I'm going to take 4,295 and I'm going to add to that 982. And that gives me 5,277. So this is how many men and women are at the game. So if I take the total number of people at the game, which is 7,104, and I subtract this number, what should be left over are the number of children. So I cannot regroup here. So I'm going to go over here. There's nothing to decompose. So I'll come over here to the hundreds. Now I have no hundreds, but I have 10 tens. But I still don't have enough to subtract here. So I'm going to have 9 tens, 14 ones. So I can subtract in the ones. I can subtract in the tens. I cannot subtract here. So I'm going to have to go over here and decompose 1,000. Now I'm ready to subtract. So I have 7, 2, 8, 1. So my answer is, I'm going to go ahead and type this too. My answer is there were 1,827 children at the football game. Okay, so on to the next problem. Go back full screen. So again, we're given another tape diagram and we're given a context. So we've got two houses here. So when you see two tape diagrams like this tells you that you're comparing something. And in this case, since we're talking about houses, I'm comparing the cost of one house to the cost of another house. And if you'll notice, I have this bracket with M. So what that means is we are trying to solve for the total of both houses together. So it looks like one house costs $215,554. The other house costs this much more than the other house. So let's get started on our story problem here. So again, I'm going to type. So let's say two houses were for sale. One house cost $215,554, and the other house cost $90,457 more. Now, since this tape diagram shows this bracket with the variable M, I'm solving for how much they are together. So my question is going to be, how much do both houses cost all together? Okay, so now I'm ready to solve this problem. So, first of all, I'm going to figure out how much the more expensive house costs. So if it costs $90,000 more, then that means I'm going to have to begin by adding $215,554 to $90,457. So when I add these together, I get 11, and I get 10, 6, 10. All right, so I get $306,000, $306,011. So this is how much the more expensive house costs. So if I was going to come over here and put in the tape diagram, I could write $306,011. So that's how much one house costs. But I'm trying to figure out how much both cost together. So this is how much one house costs. So I'm going to add to this the price of the other house, which was $215,554. So I'm going to find the total sum here. Okay, so I'll get $521,565. All right, so I'm going to type my answer here. Both houses cost $521,565 all together. All right, so we have two more problems to do. Let's take a look at problem number 3. So let's go back to full screen here so we can look at the problem. If you feel pretty comfortable writing your own problem, this would be a good time for you to go ahead and try. Your problem obviously is not going to be exactly like mine, but it should be very similar. So again, I have 3 tape diagrams. So I'm comparing three somethings. Now, the context tells me I'm comparing the weight of 3 different whales. So one whale is going to weigh 8,200 pounds. See how this box is smaller? So the next whale is going to weigh 3,500 pounds less than this whale, and the largest whale is going to weigh 2,010 pounds more than the first whale. So in order to write my story, I have to kind of think to myself, all right, I know I'm writing about 3 whales. Again, when I see that the question mark is over here, that tells me I'm trying to find the total. So when I start my problem, I don't know how much they all weigh together. That's what I'm going to ask. So I would say 3 whales were swimming in the ocean. I'm going to say that the 8,200 number is for the mother whale, okay? So the mother whale weighs 8,200, and this is the abbreviation for pounds. The baby weighs 3,500 pounds less than the mother, and the father, which is going to be the biggest, weighs 2,010 pounds more than the mother. How much all three whales weigh together? Okay, so we've got the mother whale, the baby whale, and the father whale. Okay, so the first thing, I know how much the mother whale weighs. I've got to figure out how much the baby weighs. So if it weighs 3,500 pounds less, then that tells me that I'm going to have to use subtraction to figure out how much the baby weighs. So if the mom weighs 8,000, so I'm going to label this baby. Okay, so it weighs 3,500 pounds less than the mother. So I'm going to subtract here. I can subtract in the ones and the tens, but in the hundreds, I'm going to have to decompose and make this 12. So that gives me 007, 4,700 pounds. So this is how much the baby weighs. All right, so next I'm going to go to the father. The father weighs more than the mother. So this time, instead of subtracting, I'm going to add. It weighs 2,010 pounds more. So I'm going to add. So the father weighs 10,210 pounds. So if I want to know how much this is altogether, I'm going to have to add all three of these numbers together. So I'm going to start with the father, the mother, and then the baby. I'm going to add all these together. These numbers are pretty small, so it works out pretty easily. So I've got 4 plus 7, which is 11, 13. So I'll get 23,110. So now I'm going to answer this question. How much do all three whales weigh together? So I'm just going to say the whales weigh 23,110 pounds all together. Okay. All right, let's take a look at this very last problem. There's one more. Okay, for this last problem here, you can see here that we have a total, and then we have three parts that equal a total, but we're missing a part. And it doesn't really give us any kind of idea of what our problem has to be about. All the other problems gave us a context, and this one doesn't give us a context. So the first thing I'm going to do is I'm going to draw my tape diagram, because before I even worry about solving this problem, I've just got to try to figure out what this problem is saying. So I'm going to go ahead and divide this bar into three equal parts. And you can see this line's not exactly straight. I can fix that. Okay, so I know that my total here is 26,854. So I'm going to go ahead and put that up here. I've got 26,854. And one part is 17,729. And another part is 3,731. And then the missing part is going to be just A. So I've got three parts that equal together to make 26,854. So I've got to come up with some kind of context that makes sense around these big numbers. So I'm thinking people. Other problems are about whales and houses. The first problem was about people, men, women, and children. Let's make this about something else. Let's make this about, let's do food. Let's do cupcakes. Yeah, cupcakes. That sounds good. Okay, so let's say at a baker's convention, there were 26,854 cupcakes. 17,729 were chocolate. 3,731 were strawberry. and some were vanilla. How many cupcakes were vanilla? Now, I've noticed that we've had some problems like this. I'm thinking of the exit slip that talks about the yards that Brett Favre passed, and several of you are having a really hard time figuring out how to solve for A. If I know this plus this equals 26,854, there's a couple of strategies for solving this, but I would suggest starting by adding together what you know. So as soon as I get my pen going here, excuse me. I know that I can add these two together, and that'll tell me what this is together. If I take this amount away from the total, then I should be left with A. So I'm going to start by adding these two numbers. So I've got 17,729 plus 3,731. And that gives me, add this together really quickly, 21,460. So I've got 21,460 cupcakes when I just add the chocolate and the strawberry together. When I take this part away from this total, then I should be left with how many are vanilla. So now I'm just going to subtract. So I've got 26,854. I'm going to subtract 21,460, and what I'm left with should be the vanilla cupcake. So I can subtract here, but in the tens place I cannot subtract, so I'm going to decompose. That's going to give me 15. I can subtract in the hundreds, and I can subtract in the thousands, so I only have to decompose once. So that gives me 4, 9, 3, 5. So my answer here is, and I'm going to go ahead and type this because I can type much faster than I can write. Plus, it's a lot easier for you guys to read. Okay, so my answer is there were 5,394 vanilla